Okay, welcome to the wonderful world of quadratic equations. We're going to talk about Joe Quadratic and his equations. So first of all, we're going to look at how a quadratic equation comes about. On the left-hand side here, I have a typical equation similar to the ones you've been working with. 3n plus 5n minus 2 is 0. Well, your first step might be to say, I'm going to take this minus 2 across the border, and at the same time I'm going to join these guys up and say 3n plus 5n is 8n. If I've taken the minus 2 across the border, it now equals 2 on the other side, because 0 plus 2 is equal to plus 2. Now if I take both sides, the opposite of multiplying by 8 is dividing by 8. So if I divide both sides by 8, I can end up with an answer. 2 over 8 or 1 over quarter, 1 over 4. Therefore, my answer is 1/4 or decimal 25. Everything is nice and dandy and fine and the world is singing. Now, look on the right-hand side here. Let's pretend that we have almost exactly the same question, except I've got a squared sign in front of that. Right away, it takes away that first step. I cannot go through and take 3n squared and 5n, and you cannot add them. Okay? So right away you have a problem. And that is what a quadratic equation looks like. It has a squared sign in it. Okay? So here is your general form of a quadratic equation. It has a squared sign, and it has the same letter, not squared. We will try to make the right-hand side 0. We have some number, quite often, times that squared sign. The number may be 1, so we might not write it down. We have some other number that is added or subtracted here. And then quite often, we'll have some number that is added or subtracted there, which does not have the letter x with it. Okay? That is your general quadratic equation. Okay? The first term is called your quadratic term. It's the thing that makes it a quadratic equation. Your second term is called your linear term. Okay? It forms a line if you graphed it. And your third term is called the constant term because it always has the same constant value. Since there's no x in it, that value of that third term will never change. Let's look at some examples. 5x squared plus 2x minus 3. Okay. Or you could have x squared minus 6x plus 2. Okay. Or, moving this up here, you could have 2x squared plus 5 and have no linear term. Or you might have 5x squared minus 2x equals 0, and you would have no constant term. And of course, the right-hand side may not start off to be 0. So you could have, say, 13, and this time you might have p squareds. And you might have a 5p, and you might have a 7. Okay, so the right-hand side doesn't have to start off to be 0. And of course, you don't have to always have x's. You could have p's or q's or x's or p's or r's or whatever. These guys should be the same sign though. Okay, both of those guys should be the same letter. And that is your whole family of quadratic equations. What do they all have in common? Something with a squared sign. Okay, and that's a sign that you have a quadratic equation. Now let's learn how to solve them.